guys, welcome to MoBileMaThS with Kamchirai. Today we want to look at reflection under geometrical constructions 3. Okay, so we'll use the unit square with vertices then 0, 0, 1, 0, 1, 1, and 0, 1, like that. Okay, so with this we can derive a matrix, or we can derive the column vector for A and C. I'm concentrating on y-axis and x-axis there. So I'll have them as small letter A and small letter C. So the column vector for A is 0, 1. Okay, where I'm taking it as my x and my y values there. These are x and y values there. Okay, with that I can also do for C. The column vector for C is 1, 0. Okay, now with this I can reflect my square unit, the x-axis as the invariant line and the y-axis as the invariant line. Okay, so let's do that. So I'm going to redraw, and first of all draw where we have our, let me draw. So here, this was the initial A, B, C. Now when I rotate it through the x-axis as the invariant line, I can have my image on this point here, like this, where I have my A dash and my B dash, and my C will be at the same point there. Okay, with that being said and done, I can now again look at the C values and X values. Okay, where I have got my C values and my A on those blue lines. So here I've got small letter C, and here I've got my small letter A. So the column vectors now that I have of the images, let me just use the dash to show that it's now the image. Column vector for A becomes 0, minus 1. For C becomes 1, 0. So it is not changing there. Okay, so I'm going to use this to do, or to calculate, the matrix of reflection that we have when our x-axis is the invariant line. Okay, so let's do that. So we are going to assume that our matrix of reflection, I'll use the matrix of reflection Sn, is A, B, C, D. Okay, so with that I can take those initial points for A and final after reflection for A, and have A, B, C, D being multiplied by initial point for A was 0, 1, and we got our reflected A point as 0, minus 1. Okay, so we can do the row by column matrix multiplication on the left side, and we'll get, if we do that, we'll get A by 0 plus B by 1, and we have C by 0 plus D by 1. Okay, then we'll get it is equal to 0, minus 1, like that. Okay, so if I complete there, I will have my B and my D being equal to 0, minus 1. Okay, so these are corresponding to B is equal to 0 and our D is equal to minus 1. So we take those values. Let's do the same for C. For C, our initial point was, for C, we use the same matrix A, B, C, D. Our initial point for C was, the column vector was 1, 0, and we reflected, and it remained on the same position 0, 1 there. Okay, so what it is just showing, that it is showing that is the invariant line. It is not changing, and if we multiply them, we will simply get our A and our C on the left side being equal to 1, 0. Okay, so our A is 1 and our C is 0. So if we are to write the matrix of reflection when our x-axis is the invariant line, we have it as, remember we said it's n is equals to A, B, C, D. So it becomes, our A is 1, our C is 0, our B was 0, our B was 0, and our D was -1. Okay, so this is the matrix that we have when we are reflecting on the with x-axis as invariant line or as mirror line. Okay, now let's do the same when we have our y-axis as the mirror line. Okay, so we can do the same when our x-axis, our y-axis is the mirror line. So if we do the same for our x-axis as the mirror line, we simply have the same multiplication, and we'll derive. I'll just write the final thing here. Otherwise, we'll have it on like this: reflecting A, B, C, reflecting with y-axis. This is the invariant line. We'll have our B here and our C2 there. Okay, our A2 will remain there, and we said we concentrate on A and C. So if we do that, we'll have our matrix as, let me write down there, our matrix will be A, B, C, D multiplying by our initial of C. Our initial of C is this one. This one is now C2 there. Okay, C2. So it becomes 1, 0. Okay, like that. Then our final C there, our final C is now equal to -1, 0. Okay, so if you multiply there, you will get your ABC as, -1, 0, 0, and 1. So this is the n matrix that you have when you are rotating, when you are reflecting, when you are reflecting, and your y-axis is the invariant line. Okay, or is the mirror line. So when we say invariant and mirror line, it means it's not changing. As you have seen there, our A is not changing. It is remaining on the same point. For this case, it's still on the same point because it is invariant. It is not changing. And the same that we did earlier on this one, our A, our C side here, where we said our y-axis is the invariant, so it was not changing. So that's the mirror line. So this, we take the concept from like when you see yourself in the mirror. That's how we are taking it. Otherwise, these matrix, we use them to multiply transformation. Otherwise, bye bye guys.